Welcome to you all. I hope you can see it, or it's too light or too dark. I switch up the lights so that you can see. So what are we looking at here?
Bars.
Bars. Yeah.
Delta.
The delta.
No, where is there?
Dune, coastal dune.
Coastal
Yeah.
dune.
Maybe like
Intertidal.
Oxbow bend, like the bend that it's.
A bend, yeah.
It's huge.
It's huge.
Yeah.
You can see here the ship. Huh? You can see here a ship. And this ship is about 200 meters. Huh? So yeah, so there's a lot of remarks here. Huh? And indeed, first of all, you have the perspective. I mean, this is looking at maybe 1 or 2 kilometers wide in length. We are looking here at a nuclear power plant. So we're looking landward, actually. And indeed, you say it's a delta. I would call, well, why would you say it's a delta?
Because I feel that this is the beach in here.
Yeah, you feel that, but how do you feel that?
Because it's very
Female
wide.
intuition.
No, because it seems very wide.
Yeah. It's
And
wide.
like you were talking about the ship also that it's very big, but you can see it very small, so which means that it's even wider.
The triangle shape.
And then, yeah, but also there's in the upper part also something like a river or maybe the other part of the beach or.
So what makes you tell that this is not a river?
Maybe due to the width, large width of
The width,
Yeah.
merely the width. Okay. Other people?
and also maybe
But there are many wide rivers also.
There are many wide rivers. Been in Bangladesh and you can't see the other side. It's that wide. Some people say coastal dunes. So you mean this? Well, it's a nice observation. So people say coastal, people say it's a delta, but nobody can tell me why
The sand?
it's wide. But there's sand in the rivers as well.
Yeah, but the combination.
But what makes this think you are at the coastal environment? You're right, obviously, but why? It's an intriguing picture.
It's an
The
intertidal
direction
flats.
of the dunes on the right and the left.
The direction. Yeah, but this could be a bend in the river. But there's a coastal person here, so he can tell maybe.
Intertidal flats, so
Yeah, I mean, if you look at this flat, it's wet, and there's probably a tide going back and forth, up and down, and it means that this is low water at the moment, and during high water, probably this flat is flooded, and you can see that process is going on. You can see that because of this. It's that ridge, and you know, most of you are river people, and when a river floods, it takes the sandy, what's happening here? It takes the sandy sediment, and that deposits at the side bank. It's called the levee, river levees. Used to be here in Delft as well. There used to be a tidal system, and then the sand was taken, and when the area was flooded, there was a kind of piling up of coarser sediment along the sides. And they built the main square on that because it's sand, and the other surrounding areas is peat, it's muddy. You also see that over here. Huh? So this is probably sand. Why is that sand? Because it's dry. And this is more waterish, wet. That's probably muddy. Because if this is flooded, then the coarser particles they settle earlier because they have a larger fall velocity, and they settle along these tidal levee sections. And then the finer material can be transported further inland. So indeed that's what we are seeing here. Now my profession is to model this. That's what I do, and I do that with Delft 3D. My name is Mick van der Wegen. I'm an associate professor here at IHE and a senior researcher at Deltaris. And I'm dealing with estuarine morphodynamics. So, can somebody recognize the position where we were? So this picture was taken somewhere. And just imagine that this is a power plant near a harbor. It maybe helps you a little bit. So where do we see a harbor? Here we see the port of Rotterdam. This is Delft. And here we see another harbor, it's the port of Antwerp. And the shoal that we were looking at was this one. And we were looking at like in that direction. We could see this meander of the. And the question now is, why is that shoal there? So we see many shoals here, and we see an odd shape of the estuary. And what is happening with? Why are they located over there? And what happens in 10 years? Will there still be there, these shoals? And what happens with sea level rise, for example? Are these shoals drowning, or are they totally submerged, or what is happening with this environment? So that is the things I'm studying. And in particular, the Western Scheldt is very important here because there's access to the port of Antwerp. And so you need to dredge the channels to maintain the access to the port. That makes it a very dynamic environment because you have a lot of human intervention and we have a lot of ecological values as well. The Dutch government is bound to maintain the intertidal area here. And the reason is the bird habitat guidelines. There's a lot of migratory birds. They come from Siberia, but also Scandinavia, and they migrate along the Dutch coast, and they go to Africa back and forth every year, because in Africa it's warmer, and these birds need to feed themselves, and they use this intertidal area to feed themselves. If we lose that intertidal area, we have a problem with the European Union, and with the birds also. And so that's why we need to maintain it. So I call this an estuary. Why? Well, this you may refer to as a river maybe, but this is clearly an estuary. What makes an estuary an estuary? That's basically, for me, it's where the river meets the sea. So where you have tidal motion from the sea and you have river inflow. And the sediment in this area can come from both the river and it can come from the sea, depending on the tidal movement and the tidal characteristics. And there's of course a lot of dynamic processes going on, like what happens if fresh water meets salt water. The fresh water will be on top and the salt water will go down, and you've got all kinds of mixing processes and dynamic processes that influence the water levels, the velocities in this environment. And when the velocities are influenced, you also influence the sediment transports, and with the sediment transport you influence the morphology.
So
in the end.
you want to maintain the navigational paths, but at the same time to maintain these shallow areas for the birds.
That's the equilibrium that you're looking for. Yeah. Yeah. And that is a process of that's a very difficult. It's even more complicated because you see the port of Antwerp is located in Belgium, and the Western Scheldt is located in the Netherlands. So there used to be times where they just put 2 guns here, and they were shooting every ship that wanted to access the port of Antwerp. So there's a lot of political issues over here. So the Dutch need to dredge the access to the port of Antwerp, whereas we have the port of Rotterdam. you see that there are political issues, but there's good cooperation right now. Let me put it that way. So this is a kind of the things that I'm doing. I use Delft 3D. Yes, I use Delft 3D to predict the location of these channels and shoals, at least. So Delft 3D then starts from a flat bed like this, and then we put a tide on it, we put the forcing on it, and you can see that Delft 3D is generating channels and shoal patterns. And that looks very nice, and you see that, well, you see some of these things. One of the important things is that initially you see a lot of development, and later on you see more an equilibrium. And
by why we didn't use like the longitudinal walls like the War River?
sorry?
Longitudinal walls to separate like the navigational pass from the...
Oh, that's a question related to the Western Scheldt. Yeah, let me go back. So you say, why don't you make longitudinal walls? Huh? Along this access channel, for example, like this. Well, first of all, it's very costly. Second, it's not very profitable for the dynamics of the ecological for ecosystems. They did it in part of the Seine River, I know that, in France. But on the other hand, you can also consider that they did it already. You can see them. You can see that the shape here, and if you go there, you only see dike systems. So the concrete walls that you were referring to are already there. But they are a little bit outside all there. They give room for this environment, for the estuarine environment. Yeah. And of course what happened in the past is that they were reclaiming lands. For example, this used to be an old polder, then the dike broke through and then it was intertidal again. And you could also argue like, hey, this is a shoal, why don't you put a dike around it and start using it for agriculture or for urbanization? But we don't do that anymore. It's because of the natural habitats. Yeah. Well, so this was Delft 3D. You see a lot of dynamics going on, and you also see like, hey, there's a channel shoal system developing, and the question is, like, is that a true channel shoal system or not? Huh? Is the shoals that I'm generating here, is that like it is in reality? So learning objectives today is, at the end of today, you understand basically the timescales associated with morphodynamic developments in estuaries. You understand how to assess the skill and uncertainty related to estuarine morphodynamic modeling. I have two nice case studies for you. And you are able to generate your own tidal inlet and delta with Delft 3D. And the morning lecture is then about the Western Scheldt case study I was just talking about. There was a morning exercise of a tidal basin with movies. And there's an afternoon lecture on can we trust the morphodynamic predictions, so how valuable are they? Because on the one hand you can use Delft 3D to try to understand what the patterns are and how they evolve and all the conditions for that. So it's a kind of academic exercise, as you call it. But you also have like real applications for engineers. So if we have the situation right now, can we predict what is going to happen with this shoal in 10 years from now? And then that's a case study on San Francisco Bay. And then there is this afternoon exercise on river delta development. I call this a river delta in the tidal basin. Let's see how that evolves. And well, you say, Mick, there's only two case studies. Why two? Why two? Because these are the only locations where I found more than 100 years of data. And this is already answering partly the questions that I was asking. Like these timescales are very long, and there's often not much data on this, and you need data to validate it. If you have more data of case studies that you know of, please show it to me, because then I'm very much interested. So what are we looking at here? This is the Loire estuary in France. So what do we see here?
There's shallow area over here.
Yes, a shallow area. Here, a shoal.
I think like the tidal effect is going into the river mouth.
Yeah, it is an estuary, yeah? And there's probably tide over here, and there's a river over there.
And also the sedimentation from the river is not that it may require nourishment.
Why do you say that?
Because of the deep area and the river mouth, like
Yeah.
it's normally there is a delta forming at the mouth.
Ah,
of the
yeah.
river.
Yeah, in that sense, it's not a delta thing. It is an estuary. Yeah. And some people, what's the difference between a delta and an estuary?
I think in the delta the river sediment is dominant, forming the delta.
Yeah.
But in the estuary, the erosion from the tidal, from the seas, is higher.
Yeah. Well, I once did a workshop, and for 2 days with bright people, 20 people, we talked about the definition of an estuary or a delta and what is the difference between them. And for me, the most strict definition is a delta is building up, it's providing sediment, and an estuary is receiving sediment. So a lot of these estuaries, they developed because of the Holocene sea level rise. So it's basically drowned river valleys. And because of the sea level rise, it was faster than the bed level change. That lag behind basically. A lot of these estuaries are still infilling with sediment by the sea and by the river. Whereas the delta provides so much sediment that it is building out. So that's for me the difference between an estuary. And this is probably an estuary because indeed you don't see a delta. It doesn't have delta type of features indeed. But I see rocky features. And this is typically a rocky coastline. This is probably more lowland. I see a harbor. So there's always that harbor again. And you see this urbanization at the sites, because most of these estuaries they are very valuable for trade. You see that also here at this picture, where you see 2 estuaries. One is urbanized. I think this is Southampton. And this is not urbanized. So here you can see the tidal flats, the salt marshes, maybe in tropical areas you see the mangrove forests. And this is fully urbanized. And you see, well, the question is what's happening with sea level rise? With sea level rise here, these are the fixed coastlines and you cannot go landward. And here there's much more resilience possible and much more expansion possible of this estuary. Another example is here. An estuary also with a lake there, and this is probably a wetland area, maybe tidal, maybe not tidal. It's maybe freshwater, where indeed probably with huge river flows you have a breakthrough of the spits over here, and then when the river flow is finished, then the beach is recovered again. There's a lot of dynamic processes. And here, where is this? China. Shanghai. You see the Yangtze estuary, and Shanghai. We're looking at that corner about 300 kilometers from the coast, 300 to 400 kilometers. And this particular estuary, because you have tidal movement up to 300 kilometers landward. So 300. So if you go from here to Germany and a lot more in Germany, you still would have the tidal influence because it's a totally flat area. So it's a huge system. But you also have smaller systems like this in Kalimantan, Indonesia. Not so much urbanized, but you see a lot of shrimp farms over here. And there you see mangrove forests. This is more muddy probably because of the mild slopes and not the rocky outcrops of earlier. And again, the question like what is happening with sea level rise in systems like this. If we talk about the morphological evolution of that, then you can talk about that. Well, that varies from grain sizes that build together piles of sand, and these piles of sand they make dunes or ripples in the bed, and they form landscapes, vegetated or not. And these landscapes, in the end, provide these entire systems. And what is Delft 3D capable of doing here? Which one of the four pictures? So if we are modeling with Delft 3D, what are we doing with?
The second and the third.
Second and third, yeah. I agree. This is the scale is way too small. Huh? But you can make grid sizes with Delft 3D maybe in the order of 10 centimeters or so. I've seen that. It's very timescales of seconds, for example. So that is possible. But in this region, the viscosity terms they become very important, and the dynamics of the viscosity terms and the turbulence terms, and that is solved in Delft 3D, but not on that scale. But also systems like this, I've been modeling that. And what's happening then is that you switch on the computer today, and after a month on a supercomputer here in Amsterdam, and after a month you revisit the results. And then you recognize that you had a setting wrong, and then you should have done with a different sediment size, huh? And then you do it again. So we're talking about sandy systems, but also muddy systems, and vegetated systems as well. And later on Friday, Jasper Dijkstra from Delta, a colleague of mine, he will talk about how to include the vegetation dynamics into Delft 3D. That's also possible. We talk about spatial skills, but if you want to drink something, you can.
No, it's
Okay.
I'm recording.
Okay. There's always this question of equilibrium. Equilibrium is a very nice concept. It is like people want to have their life in balance, in equilibrium, and that makes people happy. And that's the same for morphodynamic models, actually. But if you think about equilibrium, what are you thinking about?
No changes.
Happiness? Sorry?
No changes.
No changes, yeah.
Is there a change, but after a while it will come back to the first situation?
Yeah, so there's a time scale associated with that. Yeah, and so there can be a development towards equilibrium, for example. And are these
sediment discharges?
Yeah, it is.
It's like constant across the.
I was got equal input.
Yeah, equal input. But you also say this. Huh? I mean, there can be an equilibrium in a river where you have a migrating bank and then a migrating bank, but it's always the same size of the bank. So you have kind of dynamic equilibrium actually. Huh? And that is possible, for example. And it's also true that if I go to the estuary today and I look at the bathymetry, and I go back tomorrow, I see the same bathymetry. So then I would argue that it is an equilibrium, but there's a time scale involved. What are the adaptation time scales of a system like that? What is happening during a storm? Is it recovering after a storm or a large sediment supply? And a small area may be in equilibrium, but the entire system may be out of equilibrium. And you have the dynamic equilibrium and the asymptotic equilibrium that you are referring to, where the system tends towards a kind of state of less activity. Well, I know that in river basin development you have also this equilibrium relationships. And if you want to study systems like this, you go into the field and you say, okay, what is the cross-section of a river and how much discharge is going through that? And what is the relation between these two parameters, between the cross-section and the discharge? And if you do that for different systems, you can maybe derive an empirical relationship that may be true or not, because of physics. And you can do the same for tidal systems, where you say basically want to derive a relationship between your tidal prism, so that's the amount of water that flows in and out during a tidal cycle, and the cross-sectional area. And if you do that, indeed, you really see that you can derive this empirical relationship, so that there is a relationship between the size of your cross-section and the tidal prism. And that is a kind of indication for equilibrium, that supports the concept of equilibrium. The next step is then you want to explain that as well. So, back to the Western Scheldt. Shall we have a little bit of coffee? Yeah, because this is a nice point in my presentation. And then we come back in 10 minutes or so.